In this section, we're going to talk about the chain of responsibility pattern. We use this pattern in situations where we need a pipeline or a chain of objects for processing a request. Here's a real example. Let's start by adding a new package called chain of responsibility. A bit hard to spell. Now, let's imagine we want to build a web server. We don't want to get too technical about how web servers work, but at a minimum, we need to deal with the concept of an HTTP request. An HTTP request is a request that is sent from a client like your web browser or your mobile device to a web server. So let's add a new class called HTTP request. HTTP stands for Hypertext Transfer Protocol, and that is the protocol that powers our web, okay? So here's our HTTP request class. In this class, we're going to have a bunch of fields. We don't want to worry about them yet. Let's add another class called web server. In this class, at a minimum, we should have a method called handle that takes an HTTP request. Now here we have two HTTP request classes. One is declared in the java.net.http package. We don't want to use this one. We want to use the one that we just created. So we give it a request. Now, as part of handling a request, there are a number of actions that we need to perform, such as authentication. We want to make sure this is a valid request sent by a valid user. Perhaps we want to perform logging, compression, and so on. Now, we don't want to implement these tasks inside this web server class because that would violate the single responsibility principle. So we should implement each task inside a separate class. So let's add a new class called authenticator. This class is purely responsible for authenticating a request to make sure this request was sent by a valid user. So here we can have a method that returns a Boolean value called authenticate. Once again, we give it an HTTP request. Now here we could have some logic. Let's say if the request is admin and the password is 1234, that means this is a valid request. In a real application, this class needs to query a database to make sure this is a valid request. So let's go back to our HTTP request class and introduce a couple of fields: username and password. Now let's generate a constructor to initialize these fields. So generate constructor. I'm going to select the username first and then the password. This will impact the order of these parameters. Beautiful. We also need a getter for each of these fields. So Alt and Enter, create getter for username. And one more time, create getter for password. Pretty simple. Now back to our authenticator class. Here we can have some logic like this. We declare a variable called isValid, and here we write a Boolean expression. We get the username. If it's admin and the password is 1234, that means we have a valid request. So we can return it over here. Similarly, we're going to create classes for compressing and logging an HTTP request. So real quick, let's add a class called compressor. Here we should have a single method, compress, that takes an HTTP request. Now let's just print a message like compress. Also, I would like to go back to our authenticator class and print a message saying authentication. Now let's create a class for logging a request. So let's call this logger. Here we have a method called log that takes an HTTP request. And for simplicity, we're going to print a message saying log. So now each class has a single responsibility. We can go back to our web server and use these classes to handle this request. So we can create an authenticator object over here, new authenticator, and then call authenticator.authenticate this request. Now the problem with this approach is that because of this new keyword, this class is tightly coupled to this implementation. To solve this problem, we can extract an interface from this class and have our web server talk to an authenticator interface. We're going to use the same approach for performing these other tasks. So for logging, we're going to talk to a logger interface. And for compression, we're going to talk to a compressor interface. Now, even though with this approach, we'll decouple this web server from these other objects, the order of these actions will be hard-coded inside this class. If in the future, we want to disable logging for certain scenarios, we cannot do so. We have to come back and change the code in this class. Similarly, if we want to add another step like encryption, again, we have to come back and change the code in this class. This is the problem that the chain of responsibility pattern solves. With this pattern, we can build a pipeline or a chain of objects for processing a request. And that request doesn't have to be an HTTP request. It can be any type of request. We'll see how this pattern works in the next video.